All right, while this is coming up, I'm gonna grab your answer sheets. Okay, there's your answer sheets. Make sure everybody gets an answer sheet.
All three of us. Wow. You went ABCD this time.
Mhm.
This is new.
Yeah. And I found this newspaper clipping up here. Okay, you see the newspaper clipping? See the newspaper clipping?
No, you didn't.
Nice little headline there. Hey. That thing was really. Oh, I had such fun with it. Oh, that's funny. All right. So I thought you'd enjoy that. September 28th, 2016. And it's fun. All right. In-range failure. Just because the signal is in range doesn't mean it's accurate or reliable. You got that? We talk about in-range failure sometimes. You know how much trouble I went to generate that newspaper clipping? All right. And it was rough, you know. I didn't want you to see it before the PowerPoint came on. All right. This is a 96 Mazda 626 2-liter engine, C4DE transaxle, 122,653 miles. And it's basically one that you can see it was parked right at our buyer shop, you know, before we worked on it. And we're going to start out by making the assertion that any technician is worth his salt will finish what he starts. You know, I mean, you ever seen somebody start something and they just kind of taper off to nothing and not finish it, you know? I remember a few people that said they really enjoyed working on cars. Like there's one guy that was telling me when I used to hang out at Sambo's in Port Arthur, Texas back a long time ago when I was working down there on fleet maintenance. And there was some knothead that was sitting there that was trying to convince me that any time you take the thermostat out of any car, it will overheat and you'll burn the motor up. And I don't know where he came up with that unless, some of the older Mustangs had real thin radiators. If the water was flowing through them too fast, they might overheat. You know, one car at 1,000 back in the 60s might have overheated when you take a thermostat out, but some people had the idea, if you take it out, you'll always burn the motor up, you know. But anyway, this guy right here said, oh man, I love doing this kind of thing. Every time you burn one up, bring it to me, I'll rebuild it, you know. Put a thermostat back in it. But everything gets a little more complicated. More and more customers will come to us and begin their story with the words, I had an engine put in my car, or I had this work done, or I spent several $1,000s already, and I wanted you to have a look at this and see what you think. Most of the shops that I know about nowadays will usually do good work and finish what they start, but every now and then you'll run into a situation. Now some customers won't take it back to the shop that worked on it to start with. They won't even give them a chance. And people say, well, they did this over at this shop, it didn't turn out like I wanted it to. And they didn't go back and not get satisfaction. They didn't even go back and give the shop a chance to straighten it out. You know what I mean? They just wanted to go somewhere else. Well, the problem with that is, you go to this shop, and the other shop, and now it's he said, she said, and everybody said, well, we didn't do that, they did that. And, you know, you might end up in a mess. And what I always tell people when they email me, I says, go back to the shop where you had the work done and give them a chance to make it right. That's the best way you can do that, you know. All right, that's just really not fair to the shop that did the work if you won't even give them a chance to make it right. Now, occasionally, you know, you'll hear about a shop that just really sort of crashed and burned. All right, and didn't do a good job at all, and didn't care if they did a good job or not. Well, this woman and her husband paid a local shop $1,500 to stuff a salvage yard engine into the car, and because the original engine was knocking. So after the job was done and the bill was paid, the car didn't run as well as it had before the previous engine started knocking. Now, I don't know if she gave that shop a chance to make it good or not, but one way or another, we wound up with it. She wanted us to check it out rather than taking it back to the shop and install the engine, whether she had, you know, already taken it back once or twice, I don't know, I don't know. Not sure why, but she called it a vibration. And I started thinking, what do you think of when you think of vibration? You think about wheels, you think about CV axles, you think about something, you know what I mean, like that. So customers don't always describe their problems well. When we finally spoke face to face, she filled out the paperwork, it turned out the vibration was a rough idle. That's what she was talking about. That's how she was describing it as a vibration. So you basically got to figure out what they're talking about. So the idle vibration was pretty excessive. Now, whenever the little Ford Contours came out, which was basically like a 626, they had a little bit of steering wheel vibration in because that engine didn't have a balance shaft in it. And a 4-cylinder engine would have a firing event every 180 degrees, and it's inline anyway, is trying to jump up and down in the car. And so they actually had us putting dampers on the steering wheel and changing radiator mount support, just trying to smooth that thing out. It was really, really impossible. But most of your 4-cylinder engines nowadays will have a balance shaft in there that will counter the jumping up and down that the engine's trying to do just naturally. And it's worse on some makes and platforms than it is others. Well, the mill light was on, and I didn't remember her mentioning that. So before we did the highway test drive, we plugged the NGS into the DCL to have a quick look at what was stashed in the memory. The P codes we received showed the fuel control system had reached maximum compensation for both lean and rich conditions. In other words, it had gone as far as it could toward rich, and it went as far as it could toward lean. Now, when it's moving toward rich, it's corrected for a lean condition, and when it's moving toward lean, it's corrected from a rich condition. Right? So while this combination of codes sounds peculiar, it says, what in the world is it going all the way up and then all the way down? That's just really odd. But what happens is, one possible cause is an oxygen sensor that drops offline long enough during closed loop operation for the PCM to ratchet the short fuel trim way up into the plus 20s. Okay, see, this flatlines because the sensor just decided that it's going to go to sleep. Sometimes they do that. It's not as common as it used to be, but we used to see that some on these vehicles. And whenever this is flatline, you know, this cranks it right on up into the 20s, and if the short fuel trim stays there long enough for the long fuel trim to follow, see, the long fuel trim is not as sensitive as the short fuel trim, and so it's going to follow the short fuel trim. It wants to put the short fuel trim back at 0, and so if the short fuel trim's at plus 25, the long fuel trim keeps bumping it up until the short fuel trim can come back to 0, but then your long fuel trim is going to be your indicator that there's a problem, right? Well, all of this keeps going on, and it can, if the oxygen sensor is not telling the truth, it can actually cause it to start to coat the oxygen sensor with soot and that kind of thing. But then just as suddenly, in some cases, the O2 sensor will decide to wake up and start telling the truth again, but now the long fuel trim numbers are way up high. See, so what happens is it goes lean, and it keeps trying to richen it up, even though it doesn't really need to, but it thinks it does because the oxygen sensor is doing it, and it stores a code for that rich condition. And then whenever the oxygen sensor wakes back up, for whatever reason it does, I mean, I don't know how many times I've seen this, but it happens, then it has to walk back down. You see, it's already running so doggone rich because it's at plus 25, and now that this is telling the truth, it stays up high. And then it throws the opposite code. Now, anytime I've ever seen that when I was working in the field, if the car was running good and there was no other indicator anything was wrong, it got an oxygen sensor. So I was looking at calculated, and typically didn't have any comebacks on that. Well, the problem, so on and so forth. I won't go on past that. It can be intermittent. Now, there was a strategy in the early 90s on some of the F-Series pickup trucks where they had what they call a lean cruise mode. When you were driving down the road, instead of oxygen sensor switching in order to try to help fuel economy, what they would do is they let the oxygen sensor drop off to, it would have a strategy where the oxygen sensor would just go flat. And it would run really, really, really lean to try to help the fuel economy and all. Well, every now and then, it would peek in there to see if the oxygen sensor was still functional. And if it happened to do that whenever it was applying the EGR, it would literally feel like somebody ran into the back of the pickup, bam, and scare the daylights out of you. And I worked on one of those. Hooked up the portable vehicle analyzer, drove it, figured out that when I was topping off, after coming out of lean cruise, it would wham like that. You had to be driving it just right for it to do it, and that guy just happened to be one of those people. So I uploaded that portable vehicle analyzer trace to Ford, because back in those days we were on dial-up, and it took about as long as, going on a vacation to get it up there to them. Well, they pulled up that, it was looking at it like 1,000,000 times a second, and the guy called me back after he got the file and analyzed it, and he says, "You'll never fix that." He said, that's just something that's going to happen on that truck. And I said, well, what is no technical service bulletin? There weren't no reflash then, because you didn't reflash OBD1, right? So anyway, he says, no, there's not enough of them doing it, or not enough people have noticed it, where we're going to do anything about it. If we get enough customer interest, we will, or, you know, that's what the engineer told me, but I don't know what the true story was. The Mazda wasn't running right though. We got in this Mazda, the idle was too rough, and we looked into the data stream, got numbers that were anything but proper. The fuel trim readings were dancing around the -25 mark, but everything else looked fairly normal, with the exception of a mass airflow voltage that seemed a little bit too high idling. Okay? Now, I want to tell you something about the mass airflow. There was what I used to do on that Ranger, whenever I had everything that balanced out really good so that it was just like it ought to be, and it was, you know, the short fuel trim and the long fuel trim were just hovering around close to zero and everything was like it's supposed to be. I would take another mass airflow sensor that I had that was a bad one, and reading the voltage on that Ranger when it was running out on that mass airflow sensor would be 790 millivolts idling. Well, in all of your fuel trim, all I had to do was put the mass airflow sensor on it that was reading just a little more, like, you know, 0.79 millivolts. The sensor I put on there would read 0.81, which is a tiny little amount, right? But when I put that sensor on there, it was enough of a skew that it would drive those fuel trims crazy, way into the minus, because it was actually putting a little bit too much fuel in there. Oxygen sensors were picking up, fuel trims were having to try to correct for that, all because of just a tiny little difference on that mass airflow. And just a little bit. It didn't have to be, but it's a little whisper. And so that was just plumb spooky. And that was one of the final exams I would give some of my engine performance 1 people. But I actually had a video of what it was supposed to look like, and they were supposed to look at what it was supposed to look like and compare it to the scan tool and see what they saw, you know. And I could give y'all one of those similar to that if I did it right. All right. Normally, mass airflow voltage is idle on these platforms is 0.7 to 1 volt. And it's, like I say, it's tighter than that if everything like it's supposed to be. This one was reading nearly 1.2, which I knew was pretty doggone high. You know, so what had happened was, there's an idle air bleed that is made so that you can trim the idle speed on some of these Asian cars. And it's sort of like the idle air control, only it's a screw you can turn. If you back that screw out, you let more air go by the throttle plate, you can control the idle speed, change it. And sometimes when people are wanting to cover up something they don't know what to do about, they'll crack that thing and let it go. There was also one on some of your vane airflow meters that would basically, it was a trimming thing. We used to, at the Volkswagen place, we'd have to hook an exhaust gas analyzer up to a port on the exhaust and adjust the mass airflow meter idle air bleed to where it was at 1% carbon monoxide. But anyway, somebody was desperately trying to smooth the idle out by letting it idle a little faster. Well, we ran the throttle body idle setting back to where it was supposed to be, which is 650 to 750 with the idle air control disconnected and coolant fan not running. We weren't satisfied with the idle quality, let alone scan tool readings, and the mass airflow still seemed like it was a little high, but we opted for a highway test drive. So the Mazda ran like it had a crack in the air inlet tube. You know, the air inlet tube's got a crack in it on a mass airflow car. When you're getting on it, the engine will torque and open up a crack in the air inlet tube, and it'll fall on its face, and then the torque goes away and it closes back up. And so you're basically going like that. That's why it ran like that, pretty much. If he pushed his foot past the 3/4 throttle point, it would hunker down like it was starving for fuel. Right? Okay. Now, right at the 3/4 throttle level, it would buck and jump, and below that, apart from the rough idle, it ran normally. It was a little bit weak on takeoff, but for the most part, up to that half throttle level, it ran really good. The TP voltage was sweeping smoothly all the way up from 1/2 volt to about 4.6 at wide open throttle. And here's something else. If you're watching it with a scope's the best thing, but you can do it with a meter. You put your meter on the output of the TP and you go up really slow. And you watch for that voltage to climb. But if you ever see it drop out and then come back, that's going to be a problem, right? Because it's going to be paying attention to that. And if all it's got to look at is what you're doing with, what the voltage is showing that you're doing, right? Okay, even though the PCM should have been delivering full enrichment at that load. That is an open loop mode. Open loop is when you first start the engine, whenever you get up to where you're warm enough, usually within a minute or 90 seconds or something now, the oxygen sensor switching, it goes into closed loop. When you floorboard the accelerator, it goes into wide open throttle, full enrichment, open loop. You don't need the engine controller jacking around with your fuel delivery when you're trying to pass a semi going up a hill out in the country somewhere. You know, you want to be able to go. basically what you want to do. All right, so I asked Jimmy, I said, what do you think? We were encountering the opportunity for a rapid learning curve here, so let's just see what you're thinking here. He said, I think we need to check the fuel pressure, because that's what it felt like to him. You know what I mean? It felt like it to me too, you know. I said, yeah, you know, whenever you're going to pass a car and it's losing power, it doesn't matter if it's a carburetor or whatever you got. Now that throttle body injected vehicle that you were talking about, that 89 Chevrolet that we were putting the clutch in and all, that one, whenever the fuel filter stops on that one, it just hunkers down and feels like somebody stuck a potato in the exhaust pipe. It's a different feel, but on a carbureted one, like on that pickup you got, whenever you'll run out of gas and it'll come and run out of gas, you know, and all that stuff. And also you'll see stuff similar to that on regular fuel injection vehicles. We headed back to the shop, we put our $400 Mac fuel pressure gauge on it. They've got all the little adapters. You notice we had to take out a banjo bolt down here and replace the banjo bolt with a little Schrader fitting for the gauge to connect onto on that one. It was a different kind of a deal. But here we had 45 pounds of fuel pressure, and so the smart way to check it is to record the numbers with the pedal to the metal in a hard pull. So we put the gauge out there where we could see it, tape it to the windshield, whatever. This is a little annoying if it's raining. And I've also got, incidentally, a digital fuel pressure gauge. Feels like a brick in your hand. That's got a cord, and you plug it in out there, a little transducer, and pull just the cord into the car, and you got little black numbers. That's a handy little rig. It's kind of expensive, but it's handy. Now, it eats batteries for lunch, though. That's the worst part about it. Okay, unless it was reading air or water pressure, which it turned out it wasn't, the number looked good. Air pressure, water pressure, all of that can look like good fuel delivery if you're just looking at the gauge and not checking the actual quality of the fuel. All right, so with the fuel pressure data there, we had time to look a little closer at the scan tool. At wide open throttle acceleration, as we looked through our window into the system, we reiterated that both oxygen sensors were reading lean, short fuel trim was at 33, and the mass airflow sensor was reflecting only 2.78 volts. What's wrong with this picture?
It's reading lean, but mass airflow ain't catching it.
The mass airflow is topping out at 2.78, and that's the best it can do. Even at wide open throttle. Now you're going to have full enrichment, you know, at wide open throttle, because that's what it's supposed to do. All right. The mass airflow is incapable of reading more than 2.78, even though the airflow was far beyond that. That's what the computer was keying in on. If I don't see but 2.78, that's all the fuel I'm going to use, right? Okay, the flatlined O2 signals and the strong positive fuel trim number, it thought it could trust the mass airflow because the signal was responding to perceived throttle angle changes and PCM-driven idle air control adjustments. Well, see, the idle air control, the PCM will operate the idle air control and see if the mass airflow responds. When you operate the throttle, it notices the mass airflow responding and thinks it can trust it. All right, so we unhooked the mass airflow sensor out there on the road, and when we drove it, that mass airflow, you know, basically wound up going like it was. Well, the mass airflow went dark, and so it started paying attention to throttle position. And then when we replaced the mass airflow, here we were with this is what we got after we replaced the mass airflow sensor. We got 4 volts at wide open throttle, and the car ran really good. And it also idled better. All right, but anybody that studies and learns to recognize normal readings on a particular vehicle or system can usually pick out an out-of-the-ordinary set of signals and find the source of concern in short order. That's why I'm always telling you, don't neglect to look at the signals on good cars, because if you look at the signals on good cars, you'll always be able to recognize, just like the Treasury agent looking at real money so they can recognize counterfeit bills, right? Okay, understanding the nuances of a system, like on this particular one. Here's another thing. Grams per second on your mass airflow is typically going to be at idle about the same as the liters of your engine. If it's a 3-liter engine and it's sitting here idling, you're usually going to have a mass airflow reading in grams per second that corresponds with that pretty much. It's just the way it works out. Well, anyway, good for your bottom line, because if you know how to do that. Now, for example, how the PCM makes comparisons, if the PCM commands an IEC percentage increase in idling engine, I talked about that earlier. That's a rationality check, that's what they call that. Okay, when it can't detect an electrical concern, now this is an important thing. If it doesn't see an electrical problem, but it tells an actuator to do something and it doesn't see evidence that it did it, and I'm talking like shift solenoids. It'll see a shift solenoid that's electrically okay. Like until it sends a ground to that shift solenoid, it sees 12 volts coming through it. It grounds it, the 12 volts goes away, but it knows that it didn't shift into that gear, and then it'll give you a rationality check, or I mean a performance, whatever it is, check for your performance code, saying that I don't see an electrical problem, but that's not working. Basically, that's how I take that. But anyway, test question 1. Get your pen out. We're going to punch through some stuff here and make you a little smarter than you are. Technician A says most mass airflow sensors also report barometric pressure to the PCM. Technician B says a baro reading that indicates high altitude will cause an engine to run lean. Who's correct there? A, B, both, or neither? A barometric pressure reading that indicates high altitude, and that causes it to run lean. All right, we want to make sure we don't run out of time, so we're going to budge ahead. The best way to determine if a given mass airflow sensor reading is acceptable is what? Compare it to shop manual specs, measure the hertz or voltage at the sensor connector, watch the fuel trim readings while choking off air to the sensor, compare the reading to a known good sensor on the same vehicle. All right, I put a 3 up there. I left my 3, I was meant to get rid of that. Technician A says a mass airflow sensor graph should mirror TP voltage and that mass airflow readings go down when TP voltage goes up. Think about that now. The mass airflow sensor graph should mirror TP voltage. Mirror means that they ought to go opposite directions. You know what I'm saying? That's what he's saying. Technician B says engine vacuum generally goes up. Hey, did you find all them 758 shop rags in that bin over there?
Say again?
You know that big wad of shop rags in the bin?
Where at?
In that little red thing on the other side of the bin.
I'll
Okay.
get there right now.
All right, that'll do. Technician B says engine vacuum generally goes up as the mass airflow reading increases. Mass airflow reading means that the engine's picking up speed, right? All right. You gotta be thinking now. Technician A says most PCMs routinely perform rationality checks by using certain sensor readings to determine the efficacy of related output actuators. Technician B says continuous codes virtually always point to a particular sensor. And the technician B is saying, if I pull this code, I can throw a sensor at it and I'm good. Right? Which of the following is least likely to be the cause of an induction backfire? Now you know what an induction backfire is. Backfiring in the intake. Boom, boom, boom. You ever heard that? Lean exhaust mixture, bad mass airflow sensor, cross. This is least likely now. This is one of those ASE questions, trap questions. I didn't get this off of an ASE test. This is the kind of question they put on there. Cross spark plug wires, faulty downstream O2 sensor.
Lean, what is it, lean exhaust mixture?
Huh?
What is that talking about?
Lean exhaust means basically if you've got, yeah, if it's running really lean, I say lean exhaust mixture. That would, exhaust is probably a word that shouldn't even be in that question. That was a screw up on my part. Just say lean mixture. Right. All right.
Not sure. We'll come back to it.
O2 sensor values that read lean on hard acceleration may be caused by what? Uncommanded EGR flow, a stuck closed fuel pressure regulator or a pinched return line, excessive voltage drop in the fuel pump circuit, or none of the above. You need a lifeline? A misfiring cylinder due to a foul spark plug can cause A, a lean O2 signal and higher fuel trims, B, a rich O2 signal and lower fuel trims, C, an injector that doesn't operate on the misfiring cylinder, or D, both A and C. Sorry, can you get that
If
in there?
it doesn't operate, would that mean it's stuck closed? or stuck-
What do you mean doesn't operate?
The injector,
It just stops working.
like it's closed, no fuels?
Yeah, it just quits working. It was working and it quits working.
There's nothing to it. For spray.
Trying to prepare you guys for ASE testing, right? Technician A says a faulty mass airflow sensor may cause poor fuel economy on a Dodge Caravan. Technician B says a split air inlet hose between the mass airflow sensor and the throttle body can cause a Dodge Spirit to exhibit a rolling idle and a surge on acceleration. Who's correct?
Why are we talking about that?
Because they use two sensors.
A 2001 Monte Carlo is being checked for power loss under acceleration. Technician A has checked the fuel pressure in the service bay and says the problem has to be somewhere else because the fuel pressure is fine and within spec. Technician B says the fuel pressure should be monitored while the car is being driven. Who's correct? A 2001 Monte Carlo is being looked at. I think I put the same question in there twice. You guys got a bonus. When you're doing this really, really fast and you get called away from the computer, sometimes you come back, I put the same one. So 9 and 8 are gonna be the same one. Technician A says the idle air bleed screw can be used to adjust mass airflow voltage in order to offset a lean condition. Technician B says the mass airflow voltage should increase as idle air control increases. All right, everybody got all your questions answered?
Hold on a second now. Go back number one. I'm not sure about that.
They don't put it.
Technician A is true. Technician B, high altitude is gonna make it give less fuel and run lean. You got it?
And number 5.
All right, let's do it this way, we gotta hurry. The best way to determine if a given mass airflow sensor reading is acceptable is to compare the reading to a known good sensor on the same vehicle. The best way to do it. If they don't read alike, you got one that's no good. That should have been D. 3, the mass airflow sensor graph should mirror TP voltage. That's wrong. They ought to follow each other. Technician B says engine vacuum generally goes up as soon as the mass airflow reading increases. If you give it the gas, what does the vacuum do? It goes down. All right, so what should that one be? That's gonna be neither, is it? Technician A says most PCMs routinely perform rationality checks. Technician B says continuous codes, that's gonna be A only, right?
Right.
All right, which of the following is least likely to be the cause of an induction backfire? Least likely, now least likely. If you got a lean mixture, it can cause it. A bad mass airflow sensor can cause a lean mixture, right? Cross spark plug wires can make it fire in the intake. But the faulty downstream sensor, while it can affect the mixture, is typically not gonna cause this problem. That's the least likely, that's the whole point. O2 sensor values that read lean on hard acceleration can be, this is the only one that makes any sense to me, right there. Now this right here would make the pressure go high. Misfiring cylinder due to a foul plug can cause what? A and C, both A and C. It's gonna cause a lean O2 signal because all the oxygen sensor smelling is air. It couldn't care less about fuel. And if it's missing on that cylinder, the injector will shut down on most of them now, on the cylinder that's misfiring. Faulty mass airflow sensor may cause poor fuel economy on it. None of these are right because the Dodge uses MAP on most of their cars and goes Chrysler. And Monte Carlo's check. Let's do it while it's being driven. let's let B be the right answer to that one, see? We're gonna drive it, monitoring it. And technician A says the idle air bleed screw can be used, what? Also, you can't do that.